Okay, it's going. So here we've got the graphing calculator. Going to go to y equals, clear off everything that's there. And y equals negative x raised to the third power minus 5x squared plus x plus 15. Now, I'm going to have you choose the correct graph here, but I'm also going to give you a little information on how to find things like x and y intercepts and maximums and minimums and stuff like that, just so that you'll have someplace you can go back to see how to do that, because what I would show you to do here is useful all the way through this chapter. So it says they want us just to graph this. So in order to do this homework question, then I'm going to go to the window, and I'm going to assume that maybe it'll fit on negative 10 to 10.
And that's just a guess.
That's just a guess.
And if you guess wrong, you've screwed it up? Is that
No.
Is that where I'm meant,
You need to not worry about screwing it up. The only thing you can do is give it a guess as to where it might be, and if you don't see it there, make your domain wider until you can see something. Okay? So we're going to start, and the reason I'm kind of choosing that is because looking at these windows down here, I'm thinking, well, looks like they're going from negative 10 to 10 in both directions, although they didn't give me a scale. This does look like a graphing calculator window. So I'm going to assume, well, maybe they use negative 10 to 10. Is everything okay, Eddie?
Yeah, I got it. I'll talk to you about it.
Okay. So I'm just going to, basically this is the window you get when you go to Zoom number 6, which is standard. Okay? And what we see on that window looks like that. Well,
mine doesn't.
go back and make sure that you have everything in there the way that I do, and make sure that I put it in right, but it looks like I did. Make sure you entered your function correctly. Be careful and don't mix up negative signs and subtraction signs. That's very important. Do not mix up your negative signs and your subtraction signs. Try to get this down where I guess everybody can everybody see it there?
Okay.
Okay? So when we graph it, I see that, and it doesn't really look like any of those. Okay? So I'm wondering, what did they use for their scale? I don't really know, but I can tell one thing for sure. I know that it isn't behaving like that, because it doesn't come from the bottom and wiggle around and go for the top, so that's not right. I know it doesn't do that either. It doesn't look anything like that. It doesn't look anything like this. So the only one it truly looks like is A. But the thing is, I want to be positive that I did it right. Okay? So, obviously I'm seeing something here and I'm seeing another peak there, but apparently what they've done that's different is they've gone up higher and maybe down lower than what I'm seeing. So I'm going to go back to my window, and I'm going to try to adjust it to have it go from negative, let's say, 25 or 20. To positive 25, just to see if I can see it look more like what that picture does, just to be sure. So I'll hit graph again. And that does look more like it. Okay? It's still a little bit more pointed than what theirs is. But if you look real carefully, you can see this looks like it's going through at about x equals negative 2, at the point 0, negative 2, and maybe at the point 0, 1, 2, 3, 4, about negative 3.5. So if you come over here and look on this graph, you can see that it has an x-intercept that's pretty close to 0, negative 2, and another one that's pretty close to negative 3, 0. I got to get my coordinates in order. The x's come first. And it does look like the y-intercept there. Now that one, I can't tell what it is, but this one I can't tell either. So I'm gonna go back to window again, and instead of trying to count that by ones, I'm gonna try to count it by fives. So it looks like it's going like 5, 10, 0, 15. And depending on how that's scaled, if it's scaled by tens, maybe it's going through 0, 15. It definitely has an intercept that is right above the origin, not far above the origin. And the y-intercept I see looks like it's about 1.50, and that appears to be about the same on there. Okay, so the only thing I haven't done is, you know, if I really want it to look more like that, maybe their window was even way taller than mine.
It's 100, about 100.
And if I'm gonna go to 100, I can't put 20 tick marks on there, so I'll try counting by tens. So now it looks almost identical to this one, so I feel pretty good that that's the right one. But what I wanted you to understand is when you're trying to match it, first eliminate the ones that don't even look anything like it. And then when you get it narrowed down to one or two that you think do sort of look like it, then start looking and try to see where your intercepts are. And I was just guessing at where they are, but even right now I can find the x-intercepts, and I want y'all to kind of follow along with me. Everybody be on this window for right now because it'll make our life easier. Okay? So our x's go from -10 to 10. My y's go from -100 to 100. And I want us to find some x-intercepts first of all. So that's where you find what are called the zeros. Zeros, roots, and x-intercepts are all the same thing for all graphs.
This is how you go there.
Second, trace. Okay? On this one, value lets you ask for a specific value of x. I could use the word value and ask it where is x equal to 0, and it'll find the y-intercept for me. So that's what value is good for if you want to make a note. Value is good to help you find the y-intercept. You let x be 0. 0 lets you find the x-intercepts, which are also called roots or zeros of the function. Those are all three the same thing. X-intercept, roots, and zeros all mean the same thing.
So you said the 0 finds the x.
It finds the x-intercept. So I'm going to choose 0. And the first thing it asks you is, where is the left boundary? Where do you want me to start looking for a value of an x-intercept? And I'm going to find them in order. So I'm going to find this one first. So what it wants me to do when it says left bound is it wants me to move that cursor with the left arrow key. It wants me to move that little point crawling along that line until I get to the left of where it crosses the x-axis. Just anywhere. As long as you are to the left of where it crosses the x-axis. Okay? It's when you get to the left, then you press enter to say, okay, start here. And it puts a little flag up there and it says, okay, I'm going to start looking right here. Okay? And then it says right bound. So it's asking you really, where do you want me to stop looking? Where should I find it changing signs from positive to negative? Well, I need to move the cursor and tell it where I want it to stop. Now at this point, I am definitely to the right of that x-intercept. Agreed? So I hit enter and say, stop looking right here. Now, if you look, these things have to point at each other because it's saying start here, stop here. If they don't point at each other and they point that way, it's going to look down that way, it's going to look up that way, and if your x-intercept's in between, it's going to say, I can't find anything. And then it's going to get cranky and tell you to quit. So you want to make sure the arrows point at each other. And if they do, and it wants to guess, then you let it guess. You just press enter and wait for it to go. And it says the 0 is at -4.474. And you would round off however many that you're told to round off to. But you write that as -4.47 comma, 0. Write it as a point. Don't tell me it's an x value. Tell me that it's a point. It is an x-intercept, but it's a point. It has an ordered pair. Okay? So we're going to follow the same exact thing. We're going to practice again. Second, trace, choose 0, and this time I want to find that x-intercept. Okay? So I'm going to move it a little bit closer, because you don't want to be too far. It takes it longer to guess if you're too far away. So I'm going to move it a little bit closer, but to the left of where it crosses. Press enter, and then move it a little bit past where it crosses so that I am to the right of where it crosses. You can see that I'm pretty much to the right of it now, and hit enter, and my two little arrows point towards each other, so I'm good. My intersection is in between where those two arrows are. So I hit enter one more time, and it says the other 0 is at negative 2.11 comma 0. Okay? Now we have to round those off because they're not exact values. And when you get fractions like that, one of the things it tells you is that you couldn't have factored that. There's no way to factor it. All these people that tell you solve this equation by factoring, that's a terrible method to solve equations. It is a very terrible method because number one, it's hard to factor, and number two, a lot of things don't factor, so then you're stuck. You don't know how to do it. Calculator will always find your intercepts for you without factoring. Now I want you to find the third one and tell me what it is. Yeah, I want you to find the one that's on the positive side. That's right. Okay? Now practice that process, even if it doesn't ask you for it sometimes. Practice that process because that's a skill you really need to have. You need to be able to find x-intercepts. And we're going to find the y-intercept because we can. So we're going to go second, trace, and find value, and say let x be 0 and show me that on the graph. Oh, I hit graph, I'm sorry. Second, trace, value, 0. You're supposed to hit enter, not graph. And it goes right to it. It says the y-intercept is at 0, 15, which makes sense because if you let x be 0, 0, 0, what do you have left? Y equals 15. Okay? Now some other things in that section 10.3 that you may be asked to do is to find the lowest point and the highest point that you can see on the graph. When it's coming down and it goes back up and it goes back down again, it's got a valley and it's got a peak. Cubic equations, or equations that are odd degree, third degree equations, that's a cubic equation. Fifth degree equations, that's one that the highest exponent is 5. So if the highest exponent is odd, this is what it will always do. It'll either go all the ways up on one end and down on the other, or it will go the opposite, down on one end and up on the other. Okay? So it'll always have, basically its range will always be from negative infinity to positive infinity because it'll have one side that's always going up and one side's always going down. Okay? And its range is also going to be negative infinity to positive infinity because it can go on forever. But if it wants you to find maximum and minimum points, it's wanting you to find the minimum at the valley or the maximum at the peak. And you can find that. You hit second, trace, and choose maximum or minimum. And it works just like zeros. Now I think the minimum point is somewhere around there, but I don't know exactly what it is. So what I do is I go to the left of the minimum, and I go to the right of the minimum and tell it to find it. And so that point right there where that graph stops going down and starts to head back up again is at negative 3.43, comma, negative 6.9. And there really is not an algebraically easy way to find that. Next semester, we'll learn how to use calculus to find that point. But for now, we just have to know that the calculator can always find it completely accurately for us. And if I wanted to know what this peak was over here, where was the highest it ever went, I would do it the same way. Second trace, go down and choose maximum. Make sure I'm a little bit to the left of it. And then make sure I'm going back down again and tell it to guess. And it says the maximum actually was just a little bit past the x-intercept. It was actually pretty close to the or the y-intercept, but not quite. It's just a little bit beyond it. Okay? So it's about it's actually about 1 comma 15 point, maybe close to 1. Okay? But all they wanted us to do was find the graph. We found the graph, said yay, next question. This one's the same thing. Now, before I actually graph it on the calculator, remember I told you if you have an odd degree polynomial, the highest power is 3, 5, 7, 9, then one end goes up, one goes down, one way or the other. Well, if it's an even degree equation, both ends go up, or both ends go down. They point the same way. Now, what tells you...
You can rule out something then.
So you can rule some things out immediately. You know that B is not the right one. You can be sure that B is not the right one. You might want to say, well, you know, I'm pretty sure A is not the right one either because that's a quadratic equation. But sometimes a quadratic and a quartic equation can look an awful lot alike. A fourth power equation is called a quartic equation. And sometimes quartics and quadratics do look almost identically alike. So we're going to have to actually graph it to rule anything out. So we're going to try graphing it and see what happens.
Would A not be it though because it points up and that's a negative? Or does that not apply?
Okay, that's a good way to rule it out because if A is negative, that means your parabola opens down. And if A is positive, your parabola opens up. So you could rule out A based on that. Okay? You could rule out A based on that. And so we've ruled out A and B. Okay? But what you just said before I go ahead and graph it works the same way for quartic equations or any even degree power, 4th degree, 5th, 6th degree, 8th degree. Either both ends point up when A is positive or both ends point down when A is negative. So that tells you because A, my leading coefficient, the number in front of that highest power is negative, that tells me it can't be C because both its arms are going up. So by the process of elimination, without even graphing it to confirm, I'm pretty sure the right answer is D. Okay? And when you graph it, that's just going to confirm it for you. So we go in here and it's negative x to the 4th power plus 5x to the 3rd power plus 10x plus 19. And here again, that has a y-intercept that at least is positive, so we know that's probably not scaled by 1. So the window we have is still on the one we used before. We're going to leave it on that window to see what it looks like. And that does look sort of like this one. The only thing is, I bet their window goes up higher. So I'll try to raise it up to 150. And that looks very much like that one. Okay? So we know that we have the right answer. Now at home, it shouldn't have taken you anywhere near as long as it's taking me because I'm trying to explain it as I'm going along. And now you don't have to watch the help me solve this, because you can go back and watch what I did. So then we'll go to the next one. Oh, I think I missed one. Okay, this one is a cubic equation. And it's x to the third power. Now here's some ways we can think about eliminating some things. We know it's going to be one down and one up, so, okay, it's not D. Pretty sure it's not C. It's probably between A and B. How would I decide? Well, first thing I might try to do is say, well, there's that constant on the end. If I put in x as 0, y-intercept should be 2. But the y-intercept there appears to be 2, and there it appears to be 2 also. So what's actually going to decide it for us is that the coefficient of the cubic term is positive, and when the coefficient of the cubic term is positive, it goes up, then down, and back up. Okay? So it comes up from the bottom, more on goes down, and then it goes back up again. So let's see. Get the calculator. Y equals x to the third minus 3x plus 2. And I'm going to go to the standard window. So that tells me it must be that one. It comes from negative infinity, reaches a peak, goes back down, reaches a valley, goes back up.
So if it's negative, it goes down, up, and then down. If
Right.
it's positive, it goes up, down, then up.
Basically, you can think of it as what the negative coefficient does is it takes your standard graph and flips it upside down. That's really all that it does.
I'm using that Zoom standard kind of, instead of having to set windows.
Yeah, you can always do is, especially if they give you enough information to know that you're supposed to stay close to the origin to see what's going on. Now this one, you look at it and know immediately it's not going to come up, have a peak, have a valley, and go back up, because the coefficient of the cubic term is negative, so it's going to come down, go up and have a peak, and go down. So if A is positive, it's up, wiggle, and up again. If A is negative, it's down, wiggle, and down again. Okay? So this is when A is negative. This is when A is positive. Okay? Negative, positive. Right hand's up when it's positive. So that tells me, could be that one. It's not that one. It could be that one, but it's not that one. So I'm between B and C. If I look here though, I'm pretty sure I'm right that it's B, because it's positive 20, and this one appears to be crossing on the negative side. So I'm pretty sure it's B, but we'll verify it on the calculator. So negative x to the third plus 3x squared minus 16x plus 20. And they gave me a scale here, so I'm going to make use of what they gave me and actually set my window. So they're going from about negative 200 to positive 200. And it doesn't really matter about the tick marks, but since I'm not going to be able to make 400 of them, I'll count that by 20s. And that does look an awful lot like B. So we'll check the answer, and it's right. Okay? Now, based on what I told you about the polynomial functions, look at this graph, and we can look at a bigger picture of it, which would be helpful. And we see that it comes from the bottom, does this little wiggle thing, and then goes back up. So that tells me the coefficient of the first term is positive. And is it even degree or is it odd degree? Okay, it's odd degree. So it says, give the correct answer, a polynomial function of degree 3, 4, or 5. Can it be degree 4? Degree 3 does this, 4 does this, 5 does this, 4 does this. Can it be degree 4? No. No. So it's not A and it's not B. What does it have to be? Okay? And I really think acting them out helps. Everybody I've always seen before says, you know, the dancing part of it really does help. So remember, this is squared, cubic, quartic, either this way or this way, 5th power, 6th power, 7th power, 8th power, and if it's opposite, it's either both down or both up if it's even. Down and up or up and down. Your arms don't have the same position when it's odd. Okay?
Do you have a cheat sheet of all those written down?
I
Like
actually,
as in football signs.
actually, I've got a little thing, if I can find the cartoon, it's how mathematicians dance.
Yeah.
And that's exactly what it is. It says they do this, then they do this, then they do this, then they do this, and it tells you what A is on all of them.
You said right, so it's.
Odd functions, positive, odd functions, negative. Okay? Positives when your right hand's up, negatives when your right hand's down.
As for cubic.
Oh, the sign of the leading coefficient of the function is positive because the right hand's up. Okay, now this one's a little harder. Even or odd. Regardless of what it does between here and here, this tells you if it's even or odd. It's odd. What's the value of A? Where's A? Where's my right hand? It's down, so it's negative, okay? So it's odd, can't be 6, can't be 8, 10, 12, got to be 7, 9, or 11. Now let me explain to you why it might be 7, 9, or 11. It has 1, 2, 3, 4, 5, 6 peaks. The number of peaks it has tells you what the highest possible power could be. It's got 1, 2, 3, 4, 5, 6 peaks, so the highest possible power would be 7. It always has one more on the power than what it does terms. Okay?
So how does that explain 9 and 11?
So there are possibilities.
It is possible that it could be 9 and 11, but it has to be at least 7.
Okay.
7 is the lowest it can be.
Got it.
So you count your number of peaks and valleys and add 1, and that tells you what the lowest possible degree it could be. It could also be higher than that. Remember I told you that a quadratic equation and a quartic equation both could look like a parabola? But a quartic equation could also come down and make a little W in the bottom of it. 1, 2, 3 peaks, which means it's fourth power.
I hate to be stupid, but what are you saying?
Quartic is fourth power. Q-U-A-R-T, I said.
Okay, okay. I didn't
Like
know what it was.
quartiles,
Okay.
quarters,
Got it.
okay? Now, it says here the possible degrees of the polynomial can't be determined. Oh, yes, it can. It always can.
Is there any way else figuring that out, or just knowing what you just told us is the only way to figure that out, and we can't do something?
Without going through the discovery exercises that if we had had as much time as I wish we had, where I would give you x to the third power, x to the third power plus 1, x to the third power minus 3, and watch what it does to the graph and the way it makes you shift, no, you just have to know. But I'm trying to stick to the most basic stuff.
And that's fine.
This is odd,
Okay.
this is even, okay? And whatever your right hand is doing tells you the sign, even with the even ones. A is negative, A is positive. Your right hand's up, A is positive. Your right hand's down, A is negative. So because this one is this way, my right hand is down, it's negative, my leading coefficient is negative.
But I mean, you can just know that by looking, because it comes down and then.
Down and then down again.
Goes over, it's figuring out 7, 8, 9, that's gonna confuse me.
Just remember, all you do is you count the number of wiggles in between, and it has to have a power that's 1 plus 1, and that's at least how high it has to
So
be.
you start with that number, that's why I.
Yeah,
know
you
about
start
8,
with
10,
that
12.
number. You start with that number. It can't be any less than that number.
Okay.
Okay?
Well, yeah, but they have 10, 10, 12, why
Because
wouldn't I pick 8, 10, 12?
Yeah.
Because that's, just because it's even and it's
Just
starting
because
out
it's even.
odd,
Right, because
Okay.
you're.
Yeah, your behavior is odd behavior.
and that's how it's gonna work out.
Okay, it always works out. Your behavior is always
So-
odd if it does this or this.
Whatever the behavior is gonna help me determine the 7, 9, and 11
Yes,
out.
right.
Okay,
And where your right hand is helps you determine what the value of A is. Is A positive or is A negative?
I can look at it and see. if
Okay,
that-
and then the rest of it is counting the wiggles plus 1, and that tells you the lowest possible power it can have.
You say that, and the song in my head is like, wiggle, 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 so that's how I'm going to remember it.
Well,
When
you know,
she
whatever
sang
it
this
takes.
song.
Okay, here's our graph. It goes from down to up, positive A
1, 2, 3, 4, so 5 is
is the lowest it can be.
It's gonna be 5, it's gonna be even.
So it can't be 4, can't be 4. It is degree 5 is the only choice that makes any sense. And check your answer and it says yes, that's a 5th degree equation.
It's not good.
Now it says, what's the leading coefficient? Positive, right hand's up.
Oh, that's not.
Okay, now this looks nasty, but it isn't. It's an arithmetic problem. So all it is an arithmetic problem. Find f of 4.
See,
4 minus 4 is 0.
yeah, counting.
4 minus 5 is negative 1. 4 plus 6 is 10, but it doesn't matter what these are. 4 minus 4 is 0, and that does, it trashes the other, it wipes everything else out. So f of 4 is 0. Okay? For what values other than 4 is f of x equal to 4? Or is it equal to f of 4? What other values besides 4 would give you a 0? Hmm.
Well, 5. Is that what it means?
Yeah.
And then
5 minus
negative
5.
6.
5 minus 5 and negative 6 would do the same thing. So it's actually asking you something you learned back in 1100 about the zero product principle. If one of your factors is 0, then it makes the whole product 0. Well, the 4 made it 0, but -5 would make, or I'm sorry, +5 would make it 0, or -6 would make it 0, because it would make the other factors be 0. So 5, comma, get in the box.
Why don't they do that automatically?
I
I'm
don't,
annoyed by that, I'm like, come on, you know we're going there
Or
next.
sometimes I type my answer from video.
Yeah, and then
it's
you
like
look up
wrong
and
because
it's
it didn't
wrong,
fill it in.
it's not even in the box, I'm like, that's great.
okay, now it says evaluate these. G of -2. Now, you can do that in your head if you want to, but personally, I don't trust my head doing too much arithmetic anymore. I have gotten as spoiled as everybody else by the calculator. And if you remember the trick I told you, if you'll come over here and put your function in, x raised to the 3rd power plus 3x squared minus 4x minus 12, and then make sure your table, second window, is set up to be ask for your independent variable.
Okay, hold on.
Make it ask.
Yeah, can you unlock my 10.3 so I can follow on with it? No, it's not unlocked, it's telling me that I need to have 10.2. It's okay. Yeah, I guess I'm gonna have to make it.
Well, you're probably going to be better off trying to go back and do it, and then you can still pop this up if you need to. So once you set it up to ask, then go to your table, and it says what's G of -2.
Where'd you get into ask, I'm sorry?
Second window, and you have to actually put your cursor on ask and hit enter. Okay? And then second graph to get the table rather than the graph. And you just enter in the numbers it gives you. So -2, 2, -3. And for,
Oh, okay, I get where you're going.
and it makes you suspicious when you do that, because you're sitting there saying, wait, they all came out to be 0. Is this thing working right? They all came out to be 0, but they are. Okay? Now, there's something that tells you, they don't bring that out here. Oh, wait, cancel. No, I want to finish this before I do that. Let me go back up for a second to that one. The thing they didn't tell you about all of those coming out to be 0 is that you could use that information to factor that cubic equation. X cubed plus 3x squared minus 4x minus 12 would factor to x plus 2 times x minus 2 times x plus 3. I'll let you verify that for yourself. But it would be x plus 2 times x minus 2 times x plus 3. Because the values -2, 2, and -3, if you change the signs on all of them, will tell you what to put after the x and make it turn into a 0. And you should be able to tell pretty quickly that -2 times 2 times -3 is in fact -12. So it gives you the right right y-intercept when the value is x equals 0. Okay? So anytime you can come out with 0 for your y value, that means you have found a factor of the equation that it would have factored. In fact, that's actually how they create equations that will factor, is they actually start out making up the factors and then give you the end result and make you go backwards, which is the hard part. And then based on your answers from part C, what do you think the factored form of g of x is? Let's see. Okay? Using your answer from part D, what is the factored form of h of x? What does h of x have in common with g of x?
It's just gonna come
Now you can factor out the 4. So it's 4 times x cubed plus 3x squared minus 4x minus 12. So the factored form of that is the same as the answer that you gave for g of x, but it has a 4 in front of it. And then based on what you learned in the exercise, if f is a polynomial and f of a is equal to 0 for some number a, then one factor of the polynomial is x minus a. Okay? Now the answer I just got to that, when your actual factors might be different, your functions might be different, but that last answer is going to be the same when y'all do that problem. So just choose the graph of the function without using your calculator and then use your calculator to check. This is a rational function. A rational function is the function that we a lot of times say really has weird behavior. It doesn't behave rationally. Okay? The reason is because whatever the denominator of that function is, that denominator can't be allowed to be equal to 0 because we're not allowed to divide by 0. That's a problem. So what we want to do first is figure out where the function's not defined by finding out where the denominator is equal to 0. And the denominator is equal to 0 at whatever value of x would cause x squared to be the opposite of 2. Well, x squared plus 2 is never going to be equal to 0 because anytime you square a number, you get a positive answer. And when you add a positive to a positive, you still get a positive answer. So we're not going to have the behavior that you usually see on quadratic functions, on rational functions where it does like that. That's usually what you expect for rational functions because it's trying to go like this. It's trying to zoom in on a line that it can't touch because it's got something called an asymptote. So most rational functions look like that. This one doesn't because it doesn't have a possible 0 denominator. Despite the fact this tells you to choose it without using your calculator, I'm going to tell you to use your calculator. There's not a good reason not to. So we're going to see if we can see what this function looks like, and we're going to take some clues from the graphs. So we're going to go to y equals first. The key to remember here is you need to put your numerator and your denominator completely in parentheses. So that's going to be 2x squared plus 8 in parentheses, divided by, also in parentheses, x squared plus 2. And their window appears to go from -6 to 6, so that's what I'm going to make it do. Oops. So I'm going to set my window up to match what theirs looks like. And hit graph. And it doesn't take but a minute to see that that's the right graph. Okay, so select your answer. This is going to be fun. Oh, I gotta scoot back up. Okay. Find any horizontal and vertical asymptotes and any holes that may exist. Now, a hole is going to be a place where the graph is not defined. It may or may not be an asymptote. It may, in fact, just be one single point where the graph's not defined. Most rational functions have a vertical asymptote and a horizontal asymptote. Vertical asymptotes meaning a vertical line, and a horizontal one meaning a horizontal line. The horizontal asymptote has to do with the fact that maybe it can approach a certain highest value, but it can't get any higher than that. Like, for example, regardless of how big or how small we make that denominator, is the numerator ever going to be able to be less? Is it ever going to be able to be not less than, but is it ever going to be able to be more than 4? Because if I divide it by 4, it would cancel out, but 1/4 would be the only value, well, negative 1/4 would be the only value that would maybe cause it to be strange, but I don't see a way that I can ever divide it by 4. I mean, 1 plus 4x equals 4 means 4x equals 3. I guess x equals 3/4. But still, you know, the best way to find it again is to graph it first, and then we'll look at it numerically. So let's graph it. So go to y equals, the top number is just 4, so you don't really need any parentheses there. Only if you have an expression you need parentheses. Over 1 plus 4x. And since I'm not trying to match to a graph, I'm just going to stay on the window I was on and see what we can see. Now that's what most rational functions look like. They look something like that. If it has a vertical asymptote, it's basically going to be whatever this thing is flattening out against on both sides. What does it look like it's wanting to flatten out against on both sides? The x-axis. What is it sort of flattening out against on the y, on this line? That's a little harder to tell. We have to actually see what would 1 plus 4x, what would x have to be to make that be 0? So I'm going to go over here to the pencil and paper part of this for a second and say what would cause 1 plus 4x to be 0? Whoa, I think I got a little carried away there. Being very sensitive tonight for some reason. So I'm going to subtract 1 from both sides. So if x is negative 1/4, then the denominator is equal to 0. So what the calculator is actually trying to approach here is the negative 1/4. It actually does cross the y-axis up here. It actually does have a y-intercept. And if you remember that the y-intercept is where the x value is equal to 0, you can see that it actually does touch that axis. Now we could see this even better if I would make the window a little bit smaller. The line that just popped up on there is actually not part of the graph. It's your calculator trying to connect up the bottom to the top pieces of the graph. So it actually doesn't belong to the graph. But that line, if you look at it where it is, does it not appear to be at approximately x equals negative 1/4? And it doesn't make any difference how high or how low I go.
So we're gonna have to know the asymptote.
Asymptote is the value that the parts of the graph approach but can't touch, can't actually have, okay? And it has a vertical asymptote at x equals negative 1/4. And the horizontal asymptote, again, we want to look at the calculator. You can see that if it flattens out against the x-axis, and the equation of the x-axis is y equals 0. But if you want more verification before you actually do that, one of the ways you can get that verification is by tracing. And I'm going to try to come in from the other side first. So watch what happens as I trace to the left.
So you could find the one by solving that.
You set the denominator equal to 0.
But you can't do the other one that way? So
No.
just by solving.
There is a way to do it algebraically, but if you graph it, most of the time you can see it. And you can see it pretty easily.
On my calculator, if I look at my calculator, I would have said the y-axis and the x-axis, I would have said. But I didn't do all that.
Well, but the y you can almost always see. Because, you know, you said from the beginning, well, it doesn't look like it crosses the y-axis, or it doesn't look like it crosses the x-axis. And it doesn't.
See, I didn't make the line either from my graph, that's what I was saying, I didn't know, you just have to do what you're doing, I guess.
Well, there's another way you can do it. You can actually go set your table back up. Instead of to ask, set it to auto. And have it to increment your table regardless of where it starts. You can have it start at 0 or wherever. But have it to increment your table by 10 so that you don't have to sit there and count it for 1, 2, 3. And just go look at your table and you'll get an idea real quick about what happens. So if I let x get really, really big, it doesn't take long to see that y is going to get close to 0, but it's never actually going to touch 0. Okay? And the same thing if I were to have gone back the other direction. It's on the bottom side now. It's on the negative side of your x-axis. So its y values are negative. But they're just getting smaller and smaller and smaller. They're never going to go to 0 no matter how far I let that trace.
What do you actually make it do that? Enter?
I'm just holding down my up arrow button.
Oh, okay.
Can you, if you just go in and do like we were doing, I don't remember now what I did, how I got that. I think I went to, I don't know, with the 0 and the value kind of thing, doing the x and y intercept, can you just, because when I put in 0 for x, it came up with y equals 4, like it crosses.
And it crosses at 0, 4. That's the y-intercept, which tells you that the y-axis, it crosses the y-axis, so it did touch it, but it doesn't touch or cross, it doesn't have the value x equals negative 1/4. So the key thing to remember here is the way that you find The vertical asymptote is you take your denominator and set it equal to 0, set it equal to what you know it
Right,
can't
that one's
be.
easy.
That one's easy.
Yeah.
Now, there is an algebraic way on the other one. I'll go ahead and hit question help because I think it's worth looking at that part of it. So, continue, 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 continue. So y equals 0 is the horizontal asymptote, but it looks to me like all they're telling you is that as x gets larger and larger, the values of y approach 0, and you're wondering why that is. But now let's think about this. If you let x get really, really big, what does 4 times really, really big get? 4 times as big is really big, right? Does adding 1 to it change that much? So when x gets really big, what is the quantity x, 4x plus 1, what happens to it? It gets huge. What happens to 4 if you divide it by bigger and bigger and bigger and bigger and bigger and bigger numbers? Okay, let's do this numerically so that it makes sense. 4 over 1 times 1 plus 4 times 1. Let's let x be 1. That's 4 over 5, right? Okay. 4 over 5 is a fraction. Let's let x be 10. Then that becomes 4 over 41. How does the value of 4 over 5 compare to 4 over 41? Smaller. What about 4 over 401? Smaller. 4,001. 4 divided by 4,001. What happens? Smaller. What about 1 over 4,000,001? What's happening is x gets bigger and bigger and bigger and bigger, and you divide it into 4. It makes 4 get smaller and smaller and smaller. The quotient becomes smaller. Is it ever going to be 0? Can you ever divide by a big enough number? Can you divide 4 by a big enough number to make 4 disappear? No. There's always going to be some left. So that's how you figure out what the vertical asymptote is numerically. You say, well, what if I let x get really, 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 really big? Then what does this look like? Well, it looks like a really, really little bitty number for y. And little bitty numbers eventually become 0.
But the vertical one's the one you can use.
Vertical one, you just set the denominator equal
Okay,
to
it's
0.
the horizontal one, okay.
Yeah, the horizontal one you have to think about a little bit.
Yeah, I still don't have a clue.
Okay, find any horizontal and vertical asymptotes and any holes that may exist and draw the graph. And that looks like the one we just did. That is the one we just did. Okay, then this is the correct graph. Not sure why that one's in there twice, but we'll take it. Okay. Find any horizontal and vertical asymptotes and any holes, and include any x and y intercepts. Okay. X plus 4 is equal to 0 when x is equal to what? Negative 4. The horizontal asymptote, it doesn't matter about the positive 4. If x gets really, 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 really large, negative 2 gets divided by a really large number and shrinks down to nothing, but can never become nothing. So it approaches y equals 0. Now, if I graph it, it will verify that for me because this is just -2 divided by x plus 4, close the parentheses, and we'll just zoom 6 on this one just to look at the standard window, because that's what they've got. And you see that it flattens down against the x-axis as you go out that way, but it also flattens against the x-axis as you go more positive. So that's what tells you D is the right answer for the graph. It says, how can the vertical asymptote be found? Solve the equation 3 plus 4x is equal to 0 for x. And it says, what is the vertical asymptote? Well, let's see. 3 plus 4x equals 0 for x equals -3, x equals -3/4. So I think it's -3/4. How can the horizontal asymptote be found? Find the value that 4/3 plus 4x approaches as the magnitude, the value of x, gets large. Plug in bigger and bigger and bigger and bigger numbers for x. And it may help you do it this way.
How'd you get that line to draw on your graph yet?
That line, that vertical line, it draws whether you want it to or not.
Oh, when it's set on auto.
Yeah. I mean, it is actually trying to connect the top of this part of the graph to the bottom of that part of the graph. It really isn't there, but it's trying to connect itself up. So if I want to actually do what I'm telling you to do there, I go over here and put in 4 divided by 3 plus 4x, close the parentheses, and we can leave it set on ask. There's actually, it's probably just about as easy to do it this way. Let's go to ask. And go to the table and start out saying, okay, what if x is 10? What if it's 100? What if it's 10,000? What if it's 100,000? What if it's 1,000,000? What if it's 100 million? What's happening to the value of y? What is this? What's that answer right there really? 0.0004, or 1, I'm sorry, 0.0001. The next one is decimal 0.0001. By the time you get down here, it's decimal 0.00000001. But it doesn't matter how big okay, that's actually 1 times 10 to the 99th power. That's a 1 followed by 99 zeros, okay? And it just tells me, okay, fine, then it's 98 zeros and a 1, and the 98 zeros are between the decimal and the 1. Still not 0, okay? It is still not 0. So that's what tells you that if you put in large values, of x, it's gonna turn out that the horizontal asymptote is y equals 0. Okay? And then it says, what are the x-intercepts? I don't think it has any. Because it never touches the x-axis in this direction, and it never touches the x-axis in that direction. It can't. That's what the fact that we had an asymptote said. It says it never does take on the value y equals 0. And that's what an x-intercept is it's where the function has the value y equals 0. So it doesn't have any x-intercepts. Does it have a y-intercept? Yeah. Second trace, value, x equal to 0. Its y-intercept is at 1.333. And since it's going to probably want you to write that as a fraction, go back to your home screen and ask it to turn x, which is, oops, not the x, I'm sorry, alpha 1, which is y, ask it to turn that into a fraction. It says it's 4/3. Oops. Oh, sorry. It wants it as an ordered pair. And I'm the one that fusses about that. Okay? This one's, again, pretty much the same. Are we... Let's not keep on doing these, and let's see if there's anything different. Yes, I want to leave the question. Go ahead. These may all be pretty similar at this point. Okay, now this one may come out to be a little bit different. Let me explain to you why it might. What I did was I copied the equation. In this particular case, the numerator will factor into that. And because it factors into that, it's going to have the same graph as y equals x plus 3. As long as I don't let x be negative 3. Because if I let x be negative 3, then the y value would be undefined. Okay? I'm going to go back to it anyway so you can see. Okay? So what it means is that whatever weird behavior I might have expected from this, what's actually going to happen is I'm going to get a graph that looks like this. Excuse me. This is the point that would have been 3 something. Actually, it would be 3,6. Only the point 3,6 does not exist on that function. Because if No, I actually did that wrong too, I'm sorry. Because it's for -3. So the hole's gonna be right there. So it actually does exist there, but it doesn't exist at -3, 0. There's no way to get this to turn into 0 in this form. That's considered a hole in the function. That's actually what that's called, is a hole. So when we graph it, we actually are going to get a straight line. And there's the straight line that you get. And you can't see the graph, you can't see the hole on the graph, because the truth of the matter is the hole is, it's so tiny you're not going to see it. I mean, you can go all the way up to negative 2 point, you can go negative 2.9999999, but that's not 3, so it's defined there. Or you could go to negative 3.0000001 and it would be defined, but it's not defined at x equals 3, that one single instant. And you can verify that the hole is there by something I showed you earlier. Go do value and say, show me where this graph has a value -3, and it says, well, it doesn't. It leaves the y blank, okay? So you really can't see the hole. But you know it has to be there. So is there a vertical asymptote? I don't see any asymptote. It looks like a straight line. So the answer is no, there's not one. Is there a horizontal asymptote? No. Because see, if there is one, you should be able to see it on the graph, and it's not there. And what did the graph look like? Well, it looked like that. Now on the graph, they make a big deal out of showing you where the hole is. But in reality, because the hole's so tiny, you usually really can't see it.
So there's a straight line, just doesn't have vertical lines.
Yeah, even though it is a rational function, and you usually think rational functions are going to have vertical and horizontal asymptotes, in this case it doesn't, because if the numerator gets factored and you were to take out the common factors, it's equivalent to really a linear function, as long as you take into account it's got a hole. It does have a hole. And it shows you the hole. I'm going to let you do this one because I think it would be helpful for you to do this one. But what it's asking you to use various windows, and what you need to understand is this is telling you how to set x, and that's telling you how to set y. So graph that function first on that window and estimate how many vertical asymptotes it has. And you know that asymptotes are where it does that funny approaching behavior. So look at that, and but use the various windows. I'm going to let you work on that. And if you don't get it or you can't figure it out, then that's what you do when you go ask my instructor.
See, that never works for me, because you've never responded to me yet when I've sent those, and I've sent several of those, and I don't know if it's just, I don't know.
I'm not getting them.
Well, obviously,
You
I
need
say,
to contact Pearson, because I sent it to him.
Now, I usually get yours. Sometimes I'll try to answer you in a whole big message where I'll get a bunch of them, but I haven't gotten any from you lately. I got some back at the beginning.
well, that's what I told her, I had never heard back, so I didn't know, I don't know what's up with that.
When you send me an Ask My Instructor from now on, write down the homework section, the problem number, and go send me an email and a reminder, or D2L. That way I'll know to go look, because if I get them, I'll answer them right away, but if I'm not getting them, and if you send it to me and remind, I can still go look at your homework. In fact, don't even bother with Ask My Instructor then, just say, I'm stuck on this one. Go to remind and send me something. Yeah. And then I'll send you a message back and remind and say, go check D2L, I posted something, or I emailed you something. Because I want to answer your questions, but on this one, I really think it would help you to do it before I show you how to do it. There's something you learn from doing it. Okay, this is more of the same. I'm not going to keep, well, no, I will do this one because this one's a little bit different. The vertical asymptote is going to be at x equals 5. Does everybody understand why? Now, the horizontal asymptote. This one, there is actually an algebraic way to find it because there's a variable in the numerator. If the numerator is a constant, then it's basically going to be 0. There's no way to cut that constant up small enough to make it into anything that's, okay? But this one, you have a variable plus a number, and that same variable is being used in the denominator. So I'm going to come over here to question help because they actually do a good job with this. And we know how to find that. Its vertical asymptote was at x equals -1, and we knew that. And it says replace larger and larger values of x and see what value y approaches. And it says y approaches 1. Now I'm going to show you how to know that on the calculator, but then I'm going to talk to you about why it works out that way. So if we put this function in the calculator, one way you can do it, once again, let's go to the standard window. For one thing, you can see that it does flatten out as it goes far negative, and it looks like it's probably going to flatten out if I go a lot further to the right. But I can't necessarily tell what it's flattening out to. But if I go to the table, and I first let x be 10, and then I let x be 100, and then I let x be 10,000, and 100,000, and 1,000,000, 100,000,000, and a 1 followed by 99 zeros. X got bigger and bigger and bigger. What happened to y? It became 1. Okay? It became 1. And that's because if you put in the same huge number for both of these x's, after a while, the fact that you're dividing by a number that's a little bit less than that into a number that's only a little bit more than that, those numbers really get to the point where they look like they're the same value. There's going to be so little difference in them. I mean, you know, the difference in 10 million plus 1 over 10 million minus 5, both of those numbers are really going to be close to 10 million. And 10 million over 10 million is 1. So it's going to approach the value of 1. And that's why the horizontal asymptote is actually 1. Please don't think it's because that said x plus 1. It doesn't have anything to do with that plus 1. It's 1 because basically the plus 1 and the minus 5, eventually they become unimportant when x is so huge. they really don't change the value of the numerator and denominator that much when you let x get huge.
So you best bet to use the table.
You use the table just to verify and just use huge numbers. And then the correct graph, of course, I showed you the graph on the calculator. The graph looks like that, so it looks like its horizontal asymptote is at 1, 2, 3, 4. It looks like about 5, as it should. So that one, let's see, that's 2, 4, 6. Yeah, that one's probably at 5. It's probably that one. Wait. No, it is not that one because we go down and then we come from upstairs. So no, it's not that one. It would be B, because it comes from back here and down, and then it comes from the top and then down. And those don't, either one of them look anything like it. So even if it tells you don't use your calculator, yeah, use your calculator and graph it if you want to. This is another one where there may or may not be a hole in the function, or it may have asymptotes. You do it the same way you've been doing the others. All it's asking you to do here is take that function and plug in these various numbers for x. So the function is 215,000 divided by x plus 470. And that represents the cost per ton to build an oil tanker of X thousand deadweight tons when X is positive. So on your table, it's really easy to do this. You just plug in 25 and 50 and 100 and 200 and 300 and 400 and then it says round to an integer or a decimal rounded to 1 decimal place. So 434.3 413.46 would be 413.5. 377.2 320.9 279.2 and 247.1. So your calculator can be very handy. It's just a matter of learning how to use it to your best benefit. It's just a tool like anything else.
Is there any calculator restrictions for business calculator?
No, there's calculator, you better use it.
So I can get like the finite calculator, I think is what it's called?
No, you want to use the same one you're using now.
Okay, but is there a restriction in the class? That you know of, like a calculator I cannot use?
I would prefer that you not spend $200 or $300 on a calculator.
I won't be spending it, so I'm just going to
What are they letting you borrow?
I think it's a finite, she called it, I'm not quite sure. But it's one that does graphing and works out everything.
If it's a Voyager or a TI Inspire,
Oh, Inspired.
Inspired?
Yeah, it might be Inspired.
you're welcome to use it, but I don't use it in class, and I'm not familiar enough with it to help you.
Okay.
That's my only caveat. I don't care if you have it, but I'm not good enough with it to help you.
Okay.
And the asymptotes, well, for that we would graph. And given that they're looking at such large values of x, I would think we probably want to kind of do the same thing. So I'm going to go from 0 to 500 in increments of 25. And then I'm going to let the calculator figure out what y needs to be rather than me do it. So I'm going to do a zoom fit. So you just go zoom and then go to 0 fit and see what it shows me. And so this is what I see. So that window, they basically stayed positive. Let me see if y does go to a negative number. Let's go down to negative 500 and up to 1,000 and see what we see. Okay, as long as I'm staying with positive values, I'm guessing that that thing's going to keep on going out. The only place it's going to have a potential asymptote is going to be when x would be negative 470, and it says x has to be positive, right? So it would be at negative 470, but that's not really useful in our problem. Horizontal one, yeah, it probably has some kind of a limit out here, okay? So in order for me to figure out what that limit is, I'm going to look at the table and say, well, let's see, it went from 400, dropped down to 300, dropped down to 200. What if I let x be a whole lot bigger, like 1,000, 5,000, 100,000, 200,000, 500,000, million, 100 million, a trillion. See, there's million, billion, trillion. Is it ever going to get to be 0? Is there a number big enough I can put in to make it be 0? Nope. I can get real close. But actually to get 0, here again, is there a number big enough to divide into 215,000 to make 215,000 disappear?
That's, I mean, just basically, like you said, with the if it's a constant on the top.
Yeah.
That it's gonna always.
Yeah, it
be
doesn't
0
matter that
basically.
constant's huge.
So it's basically always gonna be 0?
It's always going to be, the horizontal asymptote is c equals 0. And c because it's c of x. There's no value of x that will make the cost 0. Okay? And I probably should have looked a little bit closer because some of these appear to be very much the same. Okay, did I leave? Okay, it says x-intercepts and y-intercept. The x-intercept, it didn't have one because it never went to 0. So I'm wondering how I'm supposed to tell it that. There are no intercepts. Well, you know,
Is there a lot? I thought.
there is a y-intercept though. Right there. Wait, no. I understand why there's not. There are no intercepts. The intercept is where x is equal to 0, and it says it can't be 0, it has to be greater than 0. So there are no intercepts is the correct answer. That was sneaky. Okay, the graph has an or has a y-intercept, but because x cannot be 0, that intercept is not on a practical graph. So there are no intercepts.
I know, it's the only math aspect that I've ever taken that they actually try to trick you like every time we do something.
Okay, I thought we already did this one. We already did this one. We're gonna go on.
It just should probably finish it.
No, it said I was done, and I think I tried to go on after I finished it. This is the same thing. It's having you do the same thing we did before, so that's not anything new either. This one is different, and you do need to know how to do this, so I'm going to take the time to do this. And a lot of the things that I'm telling you in this section will also apply in the other sections, but you'll have the recording of me doing some of these others from the other classes, because I'm looking at time, and we've only got about 40 minutes left. So this you do need to know how to do, and you'll be using it for other sections, okay? This says the table gives coal consumption of a country for selected years. So use the table to answer parts A through F. You're going to have at least a couple of these on the final exam. It may or may not be for the same kind of function, but you'll have a table where it says use this data to make a scatter plot. This is how you do that. I'm going to show you. You have to use the calculator. There's no other way to do it. So you go on the calculator, and the button that you press is Stat. It's the Stat button. It's right below your Delete button. It won't be hard to find. So it's Stat. You enter this data in, but be careful that you enter the data in. If it tells you let 1950 be year 0, then you do that. And it tells you that here. It says letting t equal 0 represent 1950. So when we put this data in list 1, 1950 is going to be 0. And then 1960 would be 10. And 1970 would be 20. 1980 is 30. 1990 is 40. 2000 would be 50. 2010 would be 60. And 2012 would be 62. Okay? Maybe that'll help you see them too. Well, I don't know if that's a lot bigger. And then is everybody ready to go to list 2, and I'll just read them out?
Yeah.
Okay, 493.9, 400.6, 529.3, 704.1, 906.4, 1089.9, 1045.4, 886.3. And looking at that last one tells me something happened between 2010 and 2012 to coal consumption, because it dropped significantly. So then what we do is we go to second and y equals, because we want to make a scatter plot. So it's second y equals. It's still a graph. It's a different kind of graph. Choose the very first one. They're all the same, so just choose the first one. Highlight on so that it actually makes the graph. That's how you tell it make this graph. Down arrow, and the type of graph is the very first one, so don't change anything. Your X list and your Y list should already say list 1 and list 2. So don't change that. And your mark, leave it at that little square because that makes them easier to see. Okay? So that's what your window, what this window is always going to look like. When you've entered your data into list 1 and list 2, then you go to this plot window and make it look like that. And if you don't ever change it, then you don't have to worry about it. Okay? The only thing you'll need to do is that you do need to turn it off after you're done with it. The only thing you want to do is turn them off and on. Because you can't, if you have this on and then you try to do something else on the graph, it can't graph other things on that same window. So just remember to turn it off when you're done with it. And then the next thing you do is you hit the zoom button. You've done that before. And go down to zoom number 9. Zoom 9 is specially set up to look at the stat plot window and set up a window for you without you having to make a window. Okay? So choose zoom 9 and just hit enter. And I forgot to clean off the y equals line, and I bet you did too. Hit your y equals and just clear that equation that's there. And there's your scatter plot. That's called a scatter plot. Okay? Now what we're looking for in a scatter plot is a pattern. One of the things we got to do is we got to decide which one of these looks like what we just saw. Which one of those looks like your scatter plot? Yeah, I think it's A. This one doesn't show that last point where it actually crosses the axis. And if you look, you can actually see that little point there. And that one doesn't show it. And this one shows it as actually being straight down when in fact it went down and was back up. So there was a little dip there. So it's not that one. And this one has the dip, but it has the dip. It's that last point's still not on the axis, so it definitely is the first one. And then notice what it says to use. It says use the quadratic regression feature. All of your regressions are on one screen. The screen you want to use is you want to go to Stat, which is where you went to enter your data, and go over to Calc, which is the menu in the middle, the only one you'll use. And here's what the various things are. You won't use 1, 2, or 3 at all, ever. Number 4 graphs a straight line. Your data didn't, excuse me?
Mine doesn't have that.
Let me see what yours says. Okay, you hit one of our stats. Go back and hit your stat button again. Go over to Calc. Don't choose anything. Look at the menu. Okay?
Sorry.
We're going to talk about the menu first. Okay, we're not going to use 1, 2, or 3 ever for anything. Not in this class. You might in Prob and Stats, but not in here. Number 4, you would use if your data points looked like they were a straight line. Did they? No, what kind of a function did it actually look like? Went down and up and then back down, right? That's one of those. That's a cubic, okay? This all really, yeah, we're all going to be doing dances before it's over with. The only one where I've never been any good at was the rational functions. I don't have a good way to make those lines doing what they do. But it's definitely not linear. Quadratic, you know what a quadratic equation looks like? That's a parabola. Okay, well it didn't really look like a parabola either. But it did look kind of like a cubic equation, you know, because like you said, it's, you know, one of those. Quartic is a 4th power equation, okay? Which basically means it's even powers. There's some others down here. We probably won't use most of them. This is another linear regression. You can skip over that one. This is for the section on logarithms. That's natural logarithmic regression. It's the same thing exactly as what we're doing right now. If we thought it fit, we could calculate an equation that was a log equation that would fit that data. Exponential regression, same thing. You'll see that come up when you do the sections 4 and 5. Power regression is polynomial regression. We probably won't use it, but I just wanted to tell you what it was. Power regression is the one where the powers can be even or odd, either one. And you just let it pick which one fits the best. Statisticians and mathematicians don't use power regression much because honestly, you can fit a power regression equation to anything. And it'll fit better than anything else, but that doesn't mean you ought to be using it. So what we want, this says, is to use quadratic regression. So we're going to go up here to quadratic, and we're going to hit enter. You have to tell it where did you put the x's, and where did you put the y's. You put the x's in list 1, second and number 1. Then you put a comma. You put the y's in second 2 because they were in list 2. The last thing you don't have to learn how to do, but it will make it easier on you because you won't have to copy and then type back in. So it's worth doing it. So put a comma. And what we're going to do now is we're going to tell the calculator, calculate a quadratic equation for me based on the data in list 1 and list 2. And then I want you to store it at y1. I want you to actually put that equation in for me at y1. And it's easy to do, and it always works the same way. You press the vars key. You right arrow to y vars, because that's your y variables. This is the y1, y2, y3. And you hit enter twice. And that's what your calculator screen will look like. Quadratic, list 1, list 2, comma, y1.
And how did we do that storing the right
You hit the bars key, then you right arrow to y bars. You hit enter to choose functions and enter to choose y1. And after you've done it a few times, it becomes pretty rote. And you'll do it quite a few times to practice. So when you've done that, now you can hit enter one more time to get it to go ahead and do what you told it to do. And it says your quadratic equation that the coefficient of A is negative. Well, yeah, because it went like that. Okay? And it was negative 0.038957792, which now you know why I said you don't want to have to write all that down and type it in. And B is 12.867952218, and you don't want to round these off except if my math lab tells you to. And then C is 382.51. Okay? If you press your Y equals button, you'll see that equation's already been stored over there for you. That was what that bars, Y bars function Y1 did for you. It's already stored there. So at this point, all you need to do is hit graph. And it didn't fit too good. Did not fit too good. But if you look at it, does a quadratic equation really look like it would fit? Quadratic equations are like this and like this.
Why
So why would it, I mean, because they told us to. So we did it, but does it fit?
They did say to do.
Yeah, it said on the problem, it says, use the quadratic. Okay, so we used the quadratic. It don't fit. It doesn't seem to work. What's it look like? Cubic, right? Looks like cubic.
We had a choice, would that have done it?
We have that choice and we're probably gonna do it. Okay, it says use the quadratic, get the function that approximates the data. Okay, we're gonna type that in. So it says round to 3 decimal places is needed. Alrighty then. We'll have to kind of get these side by side because my memory is not that good. So let's see, it's negative decimal 0.3 9, yeah.
Yay.
3.9,
3.895.
but it says to 3 decimal places, so 3.9. Guess I didn't want that. X to the third. I'm sorry, not to the third, x squared. My brain wants so badly for that to be cubic because I know that's what works. Plus 12.868 x plus 382.511. Dropping a using t and y as variables. Uh-oh.
It'll count it wrong.
Yeah, it will. Okay, so that must be t of y and y. So that will be y equals, and these would all be t's. Now we'll check. Okay, it was happy with that. It says graph, and which one of those look like what we got? Yeah, I agree, D.
B, B,
B?
B because of the little tail.
Yeah, that's right, it doesn't have the little dot up here on this one, whereas it did on that one, so B would be the better choice. Now it says use cubic regression. Okay, so we're gonna go back, and I'm gonna go back to the home screen. I'm gonna clear everything off, and we're gonna go stat, over to calc, down to number 6, list 1, comma, list 2, comma, vars, right arrow to y vars, enter to choose functions, enter to choose y1, and enter again to get it to do it.
I almost think it's easier to enter the formula from right there.
If you want to do it that way, it's fine.
Yeah, instead of, see, I do too.
Because you can see the numbers easier.
Yeah, that's fine if you want to do it from here. So in this case, our graph looks like y equals, now y'all have the numbers in front of you, you tell me the rounded numbers. I know it's negative.
Negative
17 x to the third, right?
or is it T or Y?
Oh yeah, it's t to the third. Plus
1.55.
3t squared minus 23.986 t plus 499.489, and we'll see if it likes that answer. It says yes, that's fine. So we need to see what that looks like, so we're going to hit the graph again. Now look how much better that fits. Okay?
And is that because the R,
Now, if you didn't put the comma y1 at the end of it,
Then it won't graph it?
it won't, no, it'll graph it, but you have to type the equation in for it instead of it doing it for you. Okay? Now, if you want to read, okay, here's what you do. Hit second and enter, Tarina. Just hit the second button and the enter button on the home screen. That's okay.
Second enter,
Okay, what does it say?
the cubic.
Okay, cubic progression, y1, y2. Put a comma.
Well, let me, can we do the line 1, line 2 then?
Yeah,
Do that first?
doesn't it already say L1, L2 for
No,
you?
no.
Okay, usually it will.
Okay, so there are those, and then how would you do the,
Bars.
open that?
Over to y bars. Choose function, choose y1, and now hit enter. And now when you get your graph, the graph will be there. Okay? That's really the advantage to that, is not having to retype it on y1. It is easier to round from that home screen. It really is. But look how much better a fit we got. Okay? So the one that fits the best, looks like it was C to me, because that's the one that has the right scatter plot on it. And then it says, which of the two functions in parts B and D appears to be a better fit for the data, and explain your reasoning. The cubic function appears to fit better because it passes closer to the data points, which it does, on the scatter plot. The quadratic did not fit well. Part C says the cubic function fits better because coal consumption is typically modeled by a cubic function. Well, no, there's nothing that says that. And the quadratic didn't fit at all, and they certainly didn't fit very well. So the first answer was the one that said it fit the scatter plot best. Okay? This one, with all that we've already done, I think you'll do fine on this one without any more help from me. But if you get stuck, ask questions. And this is another one where it tells you what window that it wants you to use, and then asks you to pick which one of the scatter plots. So again, your scatter plot, you see it from going here. Okay? In order to answer this one, what you do, since this is the average cost function, is you plug 20 units in for X, and that will give you the average cost per unit. So 900 over 20 plus 30 is 50. 900 over 50 . No, not minus 50 divided by is $18 per foot or per unit. So let's just plug it into the arithmetic. And that's what this one is too. This one you would have to do, you can do this 2 or 3 different ways, but the easiest way honestly is by graphing. You can do it algebraically. I'll show you how to do it by graphing, and then I'll show you how to do it algebraically, and then I think we'll be close to needing to wrap up. So if you're going to do it by graphing, the way you do it is first you turn that plot off by where it's on, move it over to off, and then go to y equals and clear out what we've already put in there. And we're going to enter in, I think I need to shrink my calculator down a little. 8.6x divided by 100 minus x. And then y2, cost of removing 65% to the nearest dollar. Oh, x is the percent. No, we don't need to do that either. I take it back. 8.6 times 65, and x isn't a percent, so we'll put in 65. Divided by 100 minus 65 is 35. So 15 point,
You put 36.
oh, 30, sorry about that. Let's just do that. 559 divided by 35. 1597, and it says that's in thousands of dollars, so 15,971. You move your decimal 3 places. Okay? Now, I will do something similar with the homework for 10.4 and 10.5. I will do integrity for those as well as integrity for the review. And I can probably get 10.4 and 10.5 done probably before Wednesday and put up there. I'll just go through the homework for you. And I'm not promising I'll do every problem, but I'll do as many of them as I can. And the way that I do it may very well be by going into my class and tomorrow and actually doing what I did with y'all today.
But we haven't done anything, I mean, we haven't gone over anything for 10, 4, and 5.
We haven't gone over anything for 10.4 and 10.5, but what 10.4 and 10.5 actually cover, 10.4 covers exponential functions, and exponential functions are like this. Okay? Those are like this or like this. And then logarithmic functions are like this. And let's see, what is the other thing the logarithmic function does? Sort of like that. But
So
they're
we've
they're
got to do all of this, plus study for our final, which goes over all of everything, which is.
that's why you're getting the
comprehensive,
study
it's
guide
over
for your
all.
final, so that you know what you skim over. I hate to tell you guys this, but now is when you're paying the price for Halloween.
No, this is what we're paying the price for at the beginning of the semester when we
Well,
went
that-
along and we were
yeah.
behind. No, not that 1 week that we did to take home test.
Well,
No,
that's
in the
true.
beginning.
And yes, it is partly, and that's why we didn't have near enough time to do what we need to do. And believe me, Ms. Fitz and I are taking that into account by the amount that we're gonna put on this last test. Okay? We're trying to minimize the amount of chapter 6 that's on the test. She got through 10.4, I think she said. She was gonna try to do 10.4 and 5 today.
And if we have to retake a test, we also have to.
You can study your old test if you're gonna retake one. I will, if you ask me, I'll tell you whether I think you ought to retake one or not. Because take into account, I'll give you your final exam grade in place of a retake also.
Okay.
I mean, that's usually the best favor I can give people, is to let them do the final exam instead of a
Okay.
retake,
Well, okay.
okay? And speaking of that, let me get over here and go into D2L for just 1 second. Let's see, I think I have to go into our class. Okay, this is my schedule for the week of final exams. You all are the only ones that I'm telling this. And in case I post this